question 2 of our paper 2. This June was also a stats question, of course, but we had two variables. Okay, so a question raised by many educators is whether the results that a learner achieves in an exam is dependent on the time that the learner takes to complete the exam. The average time that each of the top 10 learners in mathematics takes to complete the exam was recorded, and here's the data represented in a table and in a scatter plot. Okay, so they already went and plotted each of those points for you here. Now the first question is asking you to calculate the equation of the least square regression line of the data. Okay, and that you do with your calculator. Okay, so on your calculator, when you go to stats by mode, okay, so then you need to go to this option. It doesn't have the y equal to, and technically put the copy there, but whatever. This is the second mode. Then you put all your data in there. Now, they want you this least square regression line, so you go to the option that says reg for regression line. And there it will tell you what the A is, what the B is, and the R is. The R is also important to keep in mind. So it should tell you your A is 12,41 and your B is 0,49. Okay, please do not switch these around. It's not our usual way of writing a straight line. The X, the B, that's the second term. Okay, so our answer is 12,41 plus 0,49x. Then the second question is asking us, a learner completed the exam in 2,5 hours. Predict the mark that the learner will have achieved. Okay, so this 2,5, you go put there in x's place, and then you find your answer. And you should get 85,91, which if you wanted to, you can round to 86%. And of course, with this question, we would have CA'd with what you got by 2.1. Then they ask you to explain within the context why the regression line is not reliable. And we were kind of like open to what you said here. So some people said it is actually reliable because when they calculated the correlation coefficient, they would have gotten 0,93, which is, that's quite a strong regression line. But what we were actually looking for is they ask you, why is it not reliable? Okay, so what we were looking for is the y-intercept was 12,41. Now, that means you didn't even start the exam, but somehow you already got 12%, okay, which is not possible. So we were looking for you explaining that, okay? But yeah, as we said, we were open when we were marking, but we don't know if they're going to do that at the end of the year. Yeah, so usually when they ask you why is something not reliable, usually the y-intercept, remember that's the y-intercept, your constant term. Okay, there I just wrote it out for you. Obviously your own words, but whatever you wrote had to make sense. Calculate the standard deviation of the top 10 maths learners. Okay, so this question was a bit unclear because remember now we have two variables, so we have two standard deviations depending on if it's the x or the y. So for this question we accepted both. Your standard deviation for x was 19,68. Okay, so that's the, oops, that's not a very nice 6. And for the y it was 10,28. Okay, so the standard deviation of time was this one, which is what most people wrote. And the standard deviation for marks that they achieve was this 10,2. And then the last stats question, it is further given that there's a point in the interval of 15 random learners' marks within one standard deviation of the mean. If the mean is this, calculate the value of p. Okay, so if you look at your interval for standard deviation, you get the one with the mean minus and the other one with the mean plus theta, right? So the mean is 63.96 minus theta, which is the lower interval. Oh, sorry, they did tell you this is the interval. So P should be equal to that. And then 63.69 plus your standard deviation should give you the upper interval or upper bound of the interval, which is that. Okay, so you have two equations. Then you can go solve for theta here by subtracting. And then you obviously just go plug this in there. So this value, you go plug in there because your standard deviation is one thing at a time. So your answer should have been 24.33. And there's various different ways you could have calculated this. But yeah, you basically had to work with, we know how to find our interval for one standard deviation. And then you had to go find what your standard deviation is, plug it in, and then get your answer.